Hi, how are you doing?
Good, how are you?
Good, good, good. So, how do you find IB program grade 11 now?
Well, I'm going to grade 10 next year, and for IB program in high school, that requires that we have to do the grade 11 math during next semester.
Yes,
Obviously, it's much more difficult than what usual program we would. So, in order to prepare in advance, so I can keep up with the rest of my peers, I've decided to take on a few lessons to prepare in advance.
that's very good. And this is probably a fourth lesson, right?
Yep.
So, in the previous lessons, what all did we do?
We managed to cover lots of topics over a small amount of time. We went over Venn diagrams, surds, radicals, and a lot of challenging topics I was able to learn fairly quickly.
That's very good. And today I'm going to introduce you to a topic which you actually know much about. It is
Oh, okay.
Pythagorean Theorem. Yeah, it is Pythagorean Theorem. You start learning about it since when? Middle school, right?
Mm-hmm.
So you're introduced to this in middle school. You've done a lot of questions in grade 9 also, right?
Yep.
And now we'll have a different look towards it.
Mm-hmm.
Since you are an IB student, I thought I'll share with you some examples which normally are of interest to students in grade 11 and 12. And many students who are taking up GCSE and SAT and exams like this,
Mm-hmm.
competitive exams, for them, this is one of the most important topics.
Uh-huh.
And for all my students who want to take trigonometry later and then move into calculus, I prefer them to go through this particular video on Pythagorean theorem since we are going to see it from a different perspective, right?
Yeah,
So for you also, I think it'll be very useful.
it will for sure.
So let me share with you the lesson which I have prepared for today.
Yeah, no problem.
And I hope that really helps you moving forward. So here's my first screen. Can you see the screen?
Oh, yeah, yep.
So it says what on the top?
This is Pythagorean Theorem.
Perfect. So you can read it. So today we are going to discuss what is Pythagorean theorem. We'll also prove Pythagorean theorem. Have you ever been through the proof of
I
Pythagorean
have
theorem?
not. I have not.
Well, there are hundreds of ways to prove this Pythagorean theorem. And it is surprising that, even at this stage, students are not introduced to the proof of Pythagorean theorem.
Mm-hmm.
We'll actually begin from there. So
Yeah,
now
no
you
problem.
understand, yeah. So now you understand at which level we are talking about, correct? But to just brush up what Pythagorean theorem is, we'll take a few examples. We'll calling them as solve right triangles. As you know,
Mm-hmm.
Pythagorean theorem is actually used to solve right triangles, correct? That's the whole
Yep.
idea. So we'll see how to solve them. Finding hypotenuse when the two legs are given to us, or one of the sides when the hypotenuse is given to us. Now, do you know about Pythagorean triple?
I've heard of them, but we haven't gone over a lot for the past
Right.
years.
Yeah, for many triangles, you must have seen like the sides are 3, 4, and 5. All are integer values, right?
Mm-hmm.
So if that is the case, we call it a triple. We'll also see how to produce Pythagorean triples.
All right, all right.
Then the converse of Pythagorean theorem, which is kind of straightforward. Pythagorean theorem, as you know, is that the sum of squares of two legs is same as the square of the hypotenuse.
Mm-hmm.
But if I give you three numbers, and if the numbers are so related that sum of squares of two numbers is the third number, then these numbers could be side lengths of a right triangle. That is the
Yeah.
converse.
Mm-hmm.
Now, amongst the application, I've selected some for you, which are very useful for IB students.
Okay.
And most of the questions here are the questions from previous test papers.
Mm-hmm.
So they are going to help you a lot. I've taken questions based on circles and triangles.
Okay.
Circles and triangles. Do you see 90 degrees in circles and triangles?
We haven't, talked about a lot, but I know it's a concept for sure.
The diagram which is being displayed here, do you see one circle, a tangent line,
Yes,
right?
I do.
So the
Yes.
tangent forms 90 degrees. Do you see that?
Angle. Yes.
And so it is very interesting that from an external point, a tangent forms 90 degrees. So all of a sudden, we have a right triangle to work with. As soon as you get a right triangle, you can apply the Pythagorean theorem
Yes.
and find the side lengths. So in this case, you can find the length of the tangent from P to A, right?
Mm-hmm.
Knowing the radius of the circle, of course. Also, you must have noticed that if you have a triangle in a semicircle, that is also a right
Right
triangle.
angle. Yes, I have.
So we have a couple of examples based on such things.
Mm-hmm.
Now, 3D shapes, we have many examples, and that should be very interesting to you. And then we'll end up with a few questions from previous exams, very difficult ones.
Okay.
That would be very interesting to see. So basically, a right triangle has a right angle, which is 90 degrees, as one of its angles. So any triangle having one of the angle as 90 degrees is called a right triangle.
Okay.
Correct?
Yep.
The side opposite to the right angle is called the hypotenuse, and the other two sides are called legs. Hypotenuse is the longest side of the right triangle. Perfect. So let's see how to see or visualize a Pythagorean theorem setup. So basically, what we have here is a triangle shown here. So that is the hypotenuse. We have a right angle right there. So the triangle ACB is your right triangle. Now in this triangle, angle C is 90 degrees. Sides A and B will be referred to as legs. And side C, which is opposite to the right angle, will be referred to as hypotenuse. Okay.
Yes.
So this, you know what Pythagorean theorem is. Can you read this paragraph for me?
Yeah. In a right angle triangle with the hypotenuse C and the smaller sides A and B, C squared is equal to A squared plus B squared. You can visualize a right triangle with squares on each side. The area of the square is the square of its side length. The area of the square on the hypotenuse is equal to the sum of the areas of the squares on its legs.
Correct. So what we're trying to say here is that area of any square for that matter is equal to side square. So if the side is A, the area will be A square, correct? If the side is B, the area will be B square. If the side is C, area will be C square. So in short, we are just saying A square plus B square is equal to C square. That is, sum of these two areas, the squares formed on the legs, is same as the square of the hypotenuse side, right?
Yes.
That is what it is. So you can visualize like squares placed in three different sides, along the three different sides of a right triangle. Their sum is always same. It is important to visualize and apply when required, correct?
Yes.
Now, let us begin with the proof of a Pythagorean theorem. Perfect. So here, to prove this, let us consider a square with side length of C inscribed in a square with side length of A plus B. So what we have here is one smaller square which has a length of C, and this square is inscribed, it is within a bigger square whose length is A plus B. So I've divided this side length as sum of A and B, as you can see, right?
Yep.
So it is a square, all the three sides, all the four sides are A plus B each. It is a square, all should be same. So what is the area of the outside square? Can you tell me that?
A plus B squared.
A plus B whole square, that is the area of the outside square.
Yes.
Now the total area should be equal to the area of these four triangles shown and the area of the central smaller square, right? What is the area of a triangle?
Base times height divided by 2.
So base times height divided by 2 is the area of a triangle. We have four triangles, so we'll multiply that by 4. And then we have a square in the center, C square, we'll add that up. Now this area is same as the whole area of the biggest square, correct? Now it is a question to simplify. A plus B whole square is what?
A squared plus 2AB plus B squared.
Correct. I wrote 2AB at the end. It is A square plus B square plus 2AB, or you may say either way. On the right hand side, 4 divided by 2 is 2. So we have a term 2AB there also.
2AB, yes.
Now this 2AB on the left side and 2AB on the right side gets cancelled. So if I cancel this up, what is left? Can you read that?
A squared plus B squared is equal to C squared.
That is Pythagorean theorem.
Yes.
And you can see we have a right triangle, the smaller right triangle here. One side is A, the other one is B, hypotenuse is C. It makes sense to you?
Yep.
So we can summarize that sum of squares of the sides is equal to the square of the hypotenuse. Perfect, right? So that is a very simple proof, but a very important one. Perfect. I'll actually encourage you to look into other proofs, other ways of proving the Pythagorean theorem, okay? So let's now take some more examples. So here are three simple examples based on Pythagorean theorem. All three, what you see here, are right angles, correct?
Yeah.
So the question here is, find the missing side length in a right triangle. You have already done this exercise in grade 9 so many times. So let's review it. So you have to find x. The x is the missing side. I'm going to highlight this, and I'll take your help to find the solution. So in A, you have to find x. How will you find it? Can you tell me, please?
Well, firstly, it's important to consider that x is one of the legs. So we can reverse the Pythagorean theorem formula of a squared plus b squared is equal to c squared to find x in this question.
Okay. So that I like your concept of reversing the formula, right? I come to that stage after 3 steps. Do you see this reversing of formula? What you're trying to say is a smaller side. So square of that smaller side should be difference of the squares of the other two, right?
Yes.
So 5 square minus 3 square, which is 25 minus 9, which is 16. And as you know, the lengths are always positive. You have to take the positive square root. So x is equal to 4. And that is the triple which we were referring to, 3, 4, and 5. So as we move along, you should gather more and more information and try to see how they are related. So the second one, how will you do the second one? Can you please tell me?
Yep. So same thing as the first one. We know that x is one of the legs this time. So we reverse the formula, input the values, and we can solve for x.
So 13 square is 169, 5 square is 25. Their difference is x square. When you do the square root, 144 square root is 12, and you get 12. Now, what are the sides for this particular triangle? Can you tell me that?
For the B?
Yeah.
Yeah, so it's 5, 12, and 13.
Do you notice one thing? 5, 12, 13. Here, it is 3, 4, and 5, okay?
Yes.
So, what you see is, one of the sides, which is the hypotenuse, is just one more than the other side, right? 12 and 13. Do you see that part?
Yeah.
Well, that is kind of very important to observe. And here we have 4 and 5. Do you see that?
Difference of 1, yes.
Difference of 1. And see how we are going to use this difference of 1 in producing Pythagorean triples later.
Okay.
Now here is a slightly difficult question. Can you try to solve this particular question? Part C, please.
Well, so we know the smaller triangle, both sides are equal to 1. So with that, we can find the hypotenuse of triangle ADC. And once we have that value, input it for the triangle ABC, and then we can find the hypotenuse for x.
That is perfect strategy. And if the sides are 1 and 1, the hypotenuse has to be square root of 2.
Yes.
So now remember, if you have an isosceles right triangle, then the hypotenuse always square root 2 times the length of the legs. Very simple. So we can always say square root 2 times 1 in this case, that becomes A to C. And of course, we are interested in the longer side, so sum of squares of the other two. 4 square plus square root 2 square gives you the answer for x square. You square root and write down your answer in the radical form, 3 square root 2. Okay? So that is how we are going to solve triangles. Now let's take some more examples. Well, we have been talking about Pythagorean triple, and in this particular slide, we'll see it in more details. Set of natural numbers a, b, and c are called Pythagorean triple if a square plus b square is equal to c square. That is so simple. If they satisfy the condition for Pythagorean theorem and they are natural numbers, in that case, they are called Pythagorean triples, correct? In the previous example, we had 2 Pythagorean triples, correct? Can you name the 2 Pythagorean triples?
Yep, we have 3, 4, and 5, and 5, 12, and 13.
Perfect. This is not a triple since we had square root 2 as one of the sides.
Does not follow
so
the difference.
that is not a natural number. So the 3 numbers should be natural numbers. We have some of the Pythagorean triples straight here. 3, 4, 5, 5, 12, and 13. You could also have 7, 24, 25. Now the question is, how do we produce these triples? That is what we are going to see here.
Okay.
So here is students' activity. That is your activity. Can you please read and tell me, how will you get triples? Yes.
Generate a list of triples with the set 2n plus 1, 2n squared plus 2n, 2n squared plus 2n plus 1. where n is equal to natural numbers by completing the following table. Verify that these are all Pythagorean triples.
Perfect. So basically what you can do is you can make 3 columns for these values, which is 2n plus 1, 2n squared plus 2n, and 2n squared plus 2n plus 1. You see that difference of 1, right?
Yeah.
Where n is a natural number. That is 1, 2, 3, 4, 5, and so on. As soon as you substitute n as 1, you can calculate the values.
Yes.
The first triple which you get is 3, 4, and 5. Now, if I substitute 2, what will you get? Can you quickly calculate and tell me?
For number 2, so we go 2 times 2 is 4 plus 1 is 5.
Yes.
And then we have, and so 2 squared is 4 times 2, 8 plus 4 is 12.
And this is one more.
One more, so you just have to add 1, which is 13.
Do you see that? Likewise, you can substitute 3 and get more triples.
Yes.
So as you do this, you get triples after triples. That is one way of doing it. Another way of getting more and more triples is that if this particular thing is a triple, I could multiply this by 2. That will also be a right triangle.
Right triangle, yes.
A slightly bigger one, similar right triangle, scale factor of 2. In that case, the sides will be 6, 8, and 10.
Yes.
So you get other triples by multiplying these triples by natural numbers. So likewise, you can produce all the required triples.
Okay.
Does it make sense to you?
Yep, it does.
So easy. Now, very important thing is to remember these triples.
Yes.
Most of the questions are finding one side of a right triangle. If you already know 2 sides, then you can get an idea from the triple itself, which is the third side.
Okay.
Especially the test papers which are multiple choice, no calculator allowed, in IB curriculum.
Yes,
Yeah.
yeah.
Without calculator, right?
Allowed, yes.
Without calculator, test paper has questions where only triples could be there. You get the idea. So you have an upper hand if you know triples. Perfect?
Yep.
Let's move forward. Now what we are saying here is converse of Pythagorean theorem. Can you please read what is the converse of Pythagorean theorem?
If triangles have side lengths of a, b, and c units, and a squared plus b squared is equal to c squared, then the triangle formed will be a right triangle.
Perfect. It makes sense to you, right? That is so true. So the reverse is also true. Now the question for you is example 2. Can you please read the question and answer the question?
Yes. Which of the following set of side lengths represent a right triangle?
Tell me.
So since we automatically know from before, our triples will be 3, 4, and 5.
Good job. So you remember your triples, right?
Yeah.
You don't even have to do the calculations. Perfect. Now you can see, if I select these numbers 3, 4, and 5, 3 square plus 4 square is what? Is 5 square, right? 9 plus 16 is 25. And we know that. You normally would try with each and every value. You do 1 square plus 2 square, that is not equal to 9. And then you'll reject the first 2 and then come to the third one. But if you know your triple, you can straight away
automatically know which one's the answer, yes.
Right? Here is another way of producing your triple. Can you explore and read what have I written here?
Prove that if sides of a triangle are a squared plus b squared, a squared minus b squared, and 2ab, then the triangle is a right angle triangle.
Then the triangle is a right angle triangle, right?
Yeah.
So you could also produce your triples using 2 numbers, right? So I have drawn here, one side is a square minus b square. The longest will be a square plus 2b square, and the other leg as 2ab, right? Well, it makes sense. You can see square of a square plus b square will involve a to the power of 4 plus b to the power of 4 plus 2 times a square b square, right? Now here, if I do the square, I get 4 times a square b square. And when I add with this, which has minus 2 times a square b square, you are left with 2 times a square b square, right?
Yes.
And a to the power of 4 and b to the power of 4, right? We're going fast since you know most of it, correct? Then we have to still get to the questions which are really tricky.
Yes, yes.
But I think you learned here that there are so many ways of producing triple and to check whether the number given is a triple or not, right? This is also a very interesting formula. The side lengths could be 2ab and a square minus b squared, and the hypotenuse will be a square plus b squared. Now this is extremely important formula when you get into trigonometry.
Trigonometry,
When you go to sine theta, cos theta, and trigonometric angles, which you'll soon learn, right? you will find this. Most difficult questions in trigonometry are based on this particular formula.
Okay.
And later, when you do calculus, hugely applied. This
Okay.
formula. Okay, so I'm telling you well in advance, 2 years in advance, how you're going to use Pythagorean.
In the future. Okay.
Yes, it's that important.
Got it. Got it.
Here is a word problem for you. So in real life situation, we have situations where you will need Pythagorean theorem. Example 3. Can you please read the example?
Yep.
And yes.
Anil drives at an average speed of 60 kilometers per hour to the office. If he drives north for 1 hour and then east for 90 minutes, find the shortest distance of his office from home.
How will you solve this?
So firstly, we have to point out that 90 minutes and 60 kilometers are in 2 different units.
Okay.
So we have to convert them.
That's a very good observation. Yes. Yes.
So after we convert them, we can apply them to the Pythagorean theorem formula of a squared plus b squared to find out what the shortest distance from office to home is.
So why will you apply Pythagorean theorem here?
So if you were to visualize this question by like drawing out a triangle, you'd be able to see that it forms a right angle triangle.
Because you're going north and then you're going east. So you have a right angle triangle, correct? So that becomes the diagonal and this is your right angle triangle.
And it tells you what you need to know to solve the question.
That is it. So the idea here is, you know the speed, which is 60 kilometers per hour. You convert 90 minutes to hours, you get 1.5, right? Hours, 1.5. And you already have 1 hour on the other side. So you can figure out the 2 sides of the triangle by multiplying by 60. One will be 60, the other one will be 60 times 1.5, which will be 90. Correct?
90, yes.
So these are the steps followed. So can you please read the steps for me?
Yes. Convert 90 minutes to hours. So 90 minutes times an hour over 60 minutes gives you your equivalence of 1.5 hours. The relation between distance, speed, and time is distance is equal to speed times time. Distance traveled is 60 kilometers times 1 is 60 kilometers, as that's what the unit we're using.
Yes.
Distance traveled north is 60 kilometers over hours times 1.5 hours, which equals 90 kilometers. Then we sub this into the formula of square root of 60 squared plus 90 squared, and we get our distance of 108.2 kilometers.
Correct. So there's a typing error. We are traveling north first and then east. And when we travel east, we cover a distance of 90 kilometers. So you have 90 kilometers. This is a longer side, and that is a shorter side, and you get your right angle triangle. Perfect. Yes. Now, conversion of units is another important part which I like to highlight here. 90 minutes. We want to cancel minutes and get hours. We know 1 hour is 60 minutes. So we write it like this as shown here. And clearly, you can cancel the minutes and minutes, and you're left with hours. Do you see how the units balance out?
Yes, I do.
That's how you have to do your work. And at the end, it is important to round your answers if required, right? So we are round to a decimal place in this particular case.
Okay.
Right. So let's take another kind of example here. Here we have a 3D example. Can you please read this 3D example?
The Great Pyramid at Giza in Egypt has a square base with sides 220 meters long. The distance from the top of the pyramid to each corner of the base is 233 meters. Find the height of the pyramid.
So we need to find this particular height. It is a square base, and height will have a 90 degrees. So that means we have a right angle triangle, and we can apply the Pythagorean theorem.
Yes.
Now, can you tell me the strategy to apply Pythagorean theorem here in this particular?
So we need to figure out what our height is. So we'd have to do, find our legs of our triangle. So we know from A to E, that's 233. Yes. And then we know A to B is 220. So that also means that A to O, which is our bottom leg, would also be the same value. And input that into our formula, and then we should get our height. Okay,
so what we actually do is, this is a square, and square also has a right angle, correct? So we'll find the diagonal of the square, the whole length. So that is the diagonal. Is that okay? Half of the diagonal is A to O, okay?
Yes.
So the diagonal will be square root 2 times 220. As we learned, if the 2 sides are same, then square root 2 times the length of one side will be the diagonal, right?
Yep.
So square root 2 times 220 will be the diagonal, and A2O is half of that. So 110 square root 2 will be half of that. And we know the hypotenuse, we need to find the shorter side, difference of the squares. 233 square minus square of 110 times square root 2 will give you the answer, right? And then you can do the square root. So that is what has been done here. So can you please read the solution?
Yes. ABCD, the base of the pyramid, is a square. Triangle ABC is a right angle triangle. Solve triangle ACB to find diagonal. Half of this diagonal helps to find the height while solving triangle AOE.
Yes. So how did we find the diagonal? As explained here, AC square is AB square plus BC square. Sub in the values, they are both squares, so same values. And definitely you get 220 square root 2 when you square root this. So AC is that much. And half of AC is 110 square root 2. That becomes one side of our vertical triangle, which we're looking into. And we are looking into the shorter side, the height. So hypotenuse square minus the shorter side, we get the square of the height. And when you do square root, you get the height itself. So we can now write down that the height of this pyramid is 173.5 meters.
Yes.
You understand this strategy?
Yep.
Most of the 3D questions based on Pythagorean theorem will be solved like this. Okay. Now let's take another set of questions. So we have actually learned the basics about how to attempt questions based on Pythagorean theorem.
Yes.
Here are 4 very important questions. We'll take many more, but let's first look into these scenarios. The very first question, as you can see from the figure, we have a right triangle in semicircle, right? So if you make any triangle in a semicircle, it has to be a right triangle. Perfect.
Okay.
So that means you have to apply the Pythagorean theorem to solve it. The other question here involves rectangle. Rectangle also have right triangles, right?
Yes.
And the idea is to find the area of the green shaded region. The third one here involves tangent with a circle. That means a right triangle, right at A or at B. And the fourth one here involves square and a rhombus. And we need to find the area of the shaded region.
Okay.
Can you please read the questions and then we'll look into the strategy to solve these questions.
Question 1. AC is the diameter of the circle O in triangle ABC. Find the radius of the circle if AB is 12 centimeters and BC is 9 centimeters.
Correct. Question
2. Find area of the shaded region DEB and the rectangle ABCD as shown in the diagram. Question 3. Find tangent line AP from point 13O to the circle x squared plus y squared is equal to 25. Question 4. Area of square PQRS is 625 centimeters square. Area of rhombus QRTU is 500 centimeters square. Find the area of the shaded region in centimeters square.
So that's a multiple choice question. Now above questions could also be treated as a multiple choice question. The idea is to solve this. So I'd like you to take a moment, understand the strategy, and then let me know how will you solve the first question.
Okay. So the first question is asking us to find the radius of the semicircle. So they're telling us AC is, AB is 12 and BC is 9. So all we have to do is input that to the Pythagorean theorem formula and we'll be able to find our hypotenuse.
And half of
that. And then divided by half because they're asking for radius.
Perfect. Next question, please.
Find area. So to be able to do this, I think we first need to find, as it shows, the blue triangle divides a rectangle into 2 different right angle triangles.
Yes.
We have one, we have triangle, let's call it triangle A with the legs 7 and 3. And all we have to do is find the hypotenuse with that. Yes. And then we have the other one, we'll call that triangle C, and it's giving us 5 and 3. And as we already know for Pythagorean triple, that the other length is probably 3, 4, 5, following that rule.
Correct.
And then all we have, the next step is finding the area of the total triangle, adding the sum of the rectangle, adding the sum of the 2 triangles, find the difference, and that should equal our blue triangle.
You're right. How about the third one?
Find tangent length is, I'm not really sure. How would we solve a question?
I'll discuss this with you. This is a very difficult question.
Okay, yes.
Find the length of the tangent AP, you know the coordinates of P, you know what this point is, and you know the equation of the circle. So how are you going to do it? Okay, we'll discuss this.
Yes.
So let's go through the solutions which you're talking about, and then we'll get to question number 3 and 4.
Yep, that works.
Okay, so as you were saying, question number 1 is very simple. We are already given two sides, so we know this AC square is square of the other two sums, and then square root. We get 15 as our answer. Half of 15 is the radius, and we get our answer is 7.5. Clear,
Yes.
right? Second one, as you said, we can find area of the bigger rectangle here. So we can find the area of this rectangle, which is 7 times 3, 21. So 7 times 3 is the area of the whole thing. Within this, we have two triangles. So if I take away the area of those two triangles, I'm left with the green area triangle of our area is half base into height. The smaller sides we are always looking into, we don't even have to find the hypotenuse. Just multiply 3 and 7 divided by 2, we get area of the first triangle. Here we know from Pythagorean triple, 3 means this is also 3, 5, that has to be 4. 3 and 4 multiply, divide by 2. When you take away these two triangles from the bigger rectangle, you're left with the green shaded area of 4.5 units square. Clear? So this is a very important strategy. Looks simple at present, but in examination, it's very tricky. And normally, it is combined with other questions, especially with a circle, right? So you have to be careful. Now let's get back to our final question, which is question number 3. In this particular case, let's try to understand the scenario. Let me actually sketch coordinate plane. Whenever you see a point coordinate, that means you're working on a coordinate plane. The equation of the circle is also, you can place the circle on a coordinate plane. So let me draw y-axis right like this, right?
Yes.
And the x-axis will go kind of like this. In that case, this point here is at 0, and this point is 13, 0. That means you know what OP is?
The origin?
Origin will be 0, 0, right?
0, yes.
And OP is given to us as 13, 0.
13, 0, yes, my bad.
So the length between 0, OP is 13. So we know one side of the triangle. And we know the radius because the radius is 5 square.
Yes.
So R is 5. Once you know two sides, you can find the third side.
Oh, yeah, so you're just following the normal formula. Okay.
And that is the smaller side because hypotenuse is 15. You get the idea?
Yeah. Okay, so they make the question look very tricky at first.
Yes. Now, could you please read the solution and explain for the benefit of our students, how should we be solving this? Read the solution, please.
Yep. X squared plus y squared is equal to 25 is a circle with a center at the origin O with the radius of 5. Point P, 13, O, is on the axis 13 units away from the origin. OA is perpendicular to PA since radius is at right angles to tangent line. Triangle OAP is a right angle triangle with OP as the hypotenuse. Apply the Pythagorean theorem.
Yes. So OA square plus AP square is OP square. Plug in the values, radius is 5, AP square equals to 13 square. Rearrange and get the answer, right? Square this. And we get 12 units, correct? As such also, Pythagorean triple, if you know it, we knew this is 13, that one is 5, the other number is 1 less, 12. Do you see that? So here is a practice question for you. So you can always do another question based on this. Can you please read this question?
Yeah, no problem. Find the perimeter of the quadrilateral OAPB if PA and PB are tangents from point P, 12O to the circle O, defined by the equation x squared plus y squared is equal to 81.
Perfect. So we are talking about this quadrilateral shown. So that is examination question.
Okay.
And in this case, you are given P is not at 13, it is at 12. Do you see?
12.
So
Okay, yes.
12 and 5 will not give you that triple. So
No,
you will end up with radicals. And then you need to find the perimeter. That means this, you know, these two sides are 9, right? 9 is 81. So you'll add them and then that.
Find the answer, yes.
It's a very good question here. Okay. Now let's look into the fourth question on that paper, which was area of the square was given to us and the area of the rhombus is also given to us. We know these two areas. They actually help us to find the sides. So
Okay.
square of 625 tells you that this side should be 25 times 25,
yes.
right? And now we know this is 25, right? We know this is 25, but the area of this is given to us as 500 rhombus, right?
Yes.
So rhombus area is what? It is base times height. So basically, extend this, and that is the height. So 25 times what is 500? 20, correct? So we know the height is 20 in this case. So you know this height is 20 means this distance is 20.
Also
correct?
20, yes.
But the total was 25, so this is 5. And now I think you can find the area of shaded region.
Okay.
You get the idea. Did you understand the approach?
Yes, okay.
I like you to read
a lot of steps to first be able, that's the part.
Thinking. This is one of the most difficult questions which you can get in this particular unit, okay?
Yes.
I like you to go through the solution and read the steps involved.
Area of square PQRS is equal to 625 centimeters square. Side length QR is the square root of 625, which is 25 centimeters. Rhombus side lengths will also be 25 centimeters as well. Area of rhombus QRTU is 500. Base times height is equal to 500. So to be able to find the height, just reverse the base times height formula and we get 20. Let V be on QP so that TV and QP. VQ is our height, which is 20, and PV is equal to PQ minus VQ. Sub in the units is 25 minus 20, and we get 5 centimeters. Do this, we can see that triangle VTQ is a right triangle. All we have to do is sub in the values of QT and QV to our Pythagorean theorem formula of 25 squared minus 20 squared, and we'll be able to find our final answer.
Perfect. Since this is a rhombus, all sides are equal. We know that is 25. This side is 20. So from here, difference of squares will give you the square of that, which is 15 length. And that is how you will get it. So I'd like you to pause the video for a minute, look at it carefully, understand the approach, since this is one of the most important approaches to follow. And most intricacies on using Pythagorean theorem, right? So see how complicated the question could be, right?
Yes, very.
Now, let me take you to another level. We're saying application in 3D shapes, right? We did take up one particular shape, right? Pyramid, but there could be other kinds of shapes. So in this particular example, we have a rectangular prism here, we have a pyramid and a wedge. Now, dealing with a wedge is a very difficult thing, but look at it very carefully. Do you understand a wedge?
Yes.
So wedge has got something high at the other end, but this is at right angles, right? You have a right angle there. On the other end, you know, the way this triangle has been shown, it is again a right angle, correct? I would like you to read these 3 questions and think about it.
Okay. Find the longest diagonal length AD in the rectangular prism with dimensions of 3, 4, and 8 units. Question 2. Find the height of the square base prism shown in the figure. Question 3. A wedge with square base is shown in the figure. Find the length DC if the sides of the square are 1.2 meters each and the height AB is 1.24 meters.
Correct. So when you have to find the triangles, now you know it's as good as in the first case solving 2 triangles, right? So you can solve this triangle at the bottom base, get the value of x. Once you get x,
you'll be able to solve for y.
Very simple question, right? Not very difficult. On the other hand, also we have 6 and 6. These sides are equal. We did the pyramid question. We know this is 6 square root 2, right?
Yes.
And half of that is 3 square root 2, right? So 3 square root 2 and 10. So 10 square minus square of 3 square root 2 will give you square of the height. And when you square root, you get your answer. See how simple it has become now to think of?
Yes. Once you get into the flow of using the formulas, then yes, it becomes simple.
Very simple, correct? Now here we are saying a wedge with a square base. Square base means I'm giving you this side as 1.2 meters. That is also 1.2. So once I know 2 sides, I can find the hypotenuse. But in this case, we basically need to find, well, that could be also one parameter to find some examples. But in this particular question, what are we asking for? Find the length DC. We are asking for this particular length, right? DC. So we have to solve the vertical triangle. So first we have to get E to C, right?
Yeah.
E to C is a diagonal. And we know this is 90 degrees. So you can always find this diagonal using the 2 sides of 1.2 and 1.2, right?
Yes.
And then you know the height and you can find the third side. Does make sense to you?
Yes, it does.
So here is a quick solution to these, as you can see from here. So
Okay.
nothing much. To find the value of x, we just said x should be, first we have to kind b to d, right? So we keep that as a square itself. There is no point finding square root, since in the second question, second triangle, we have to use the square itself, right?
Right, yes, true,
We'll just keep the square of BD square, so that when AD square is asked for, we'll use 3 square plus the square of BD square, which is 8. And that gives you 89, and square root gives you the longest diagonal, right? That is also referred to as the longest diagonal in a particular prism. In second case, which is question number 6, as I was saying, the diagonal total length will be 6 square root 2. Half of that, 3 square root 2. And then we do 10 square minus.
Input the values,
And get around.
Okay.
Simple as that. So with the help of this particular video so far, you can see you can actually sail through these difficult questions so easily, right?
Yes.
And when you're talking about the wedge, which is such a difficult question, right?
Yeah, it was very hard to understand at first.
Very, very difficult. So you can now find the value of e to c as we have done this. And you know it is square root 2 times the length, right? Because your square is involved. Simple as that. And once you know this is square root 2 times 1.2, that is given to us as 1.24. Just apply the Pythagorean theorem.
Yes, and then you'll get your final answer.
How simple it is. Do you see that part?
Yes.
You'll be given enough time to solve such questions in your test paper. You can nail them in 1/3 of the time. Perfect?
Yep.
Now, something more. There you go. So this time what I've done here is we have squares involved. We have circles and triangles and all kinds of things. Right? Can you please read question number 8?
Find the distance of the chord AB from the center O of the circle with radius of 10 centimeters if the chord length is 12 centimeters.
So that is a triangle inscribed in a circle. You could say that, something like this, not really inscribed. But chord length is the length when you connect 2 points on the periphery of a circle, right?
Okay.
So the chord will be, the longest chord will be the diagonal itself, but other chords will be less than the diagonal.
The diagonal, yes.
But the important thing here is that the two ends are radii away, right? Same radius. So always you have isosceles triangle. If you have an isosceles triangle, you draw a right bisector. Right bisector, divide the 2 lines and go through the center, right? Go through the center. So you always get a right triangle.
Yes.
And Pythagorean theorem helps you.
You just have to, okay.
Does it make sense?
Yeah.
Now can you read the question and tell me the approach to solve it?
Okay. So we know that, so the chord length is 12. So that means CB or AC is going to be 6 because half of that is 12.
Yes.
And it's also telling us that the radius is 10. So if OB and OA are going to be 10, and all you have to do is just input the formula.
So you find the third side, which is smaller of the two.
Yes.
In terms of squares, square root gives you the answer. Question number 9, please.
A boat travels 12 kilometers at a bearing of 30 degrees from port B to port A, and then 10 kilometers to port C at a bearing of 120 degrees. How far is the boat from the starting point?
Do you know the bearing angles?
We went over it, but we weren't able to, kind of more go into it.
Okay, it's a good idea to understand them now.
Yes.
Now, bearing angle is always measured from north, and it is written in 3 digits, right? 0, 30. We are not writing 30 degrees. 0, 3, 0 degrees, okay?
Okay.
So it is measured clockwise from north. So when I say a boat traveled 12 kilometers at a bearing of 030 degree, that means from north, it is 30 degrees as shown here.
Yeah.
And distance is 12 kilometers. Do you get that idea now?
Yes.
Now, second time it says from port B to A, port A, and then 10 kilometers to port C. So it travels from B to A first, right?
Yes.
And then from A to C at a bearing of 120. Then again you have to measure from north, right? So from north as shown by the arrow, clockwise is 120 degrees. So in that direction, it covers 10 degrees.
10 kilometers, okay.
Yeah, 10 kilometers. Now, I'm saying this is 90 degrees. Can you give me an explanation for that? Why this angle is 90 degrees?
Because as you can see, the drawing has formed a right angle triangle.
Why?
That automatically, because following the bearings and the angles that it moves at, it forms a right angle triangle.
Let's do the calculation. This is a very, very important calculation. Always, it will not be 90 degrees. Since we are getting into this exercise of applying the Pythagorean theorem, we have taken this particular case.
Okay.
Now, you will apply trigonometric formulas to find.
Oh, okay.
Right? So it's a very difficult question otherwise. Okay. But fortunately, you remember two parallel lines and a transverse line? So this sum is 180. Do you see that?
Yes, I do. Yes.
Internal sum. So 180 means 180 minus 30, it gives you 150 here, correct?
Mm-hmm.
Now, you already, if you have a point, total angle should be 360.
50, yes.
360. So we already have 150 and 120. What is left? 360 minus 150 minus 120 is 90 degrees.
90. So then we can automatically know that it's a right angle triangle. Okay.
Now, since it is a right angle triangle, we'll apply the Pythagorean theorem and the side length BC will be calculated.
Okay.
Now?
Yes.
Yeah, so we are going to learn trigonometry and use cosine law to find this particular length. So here you can understand the importance of Pythagorean theorem in solving many problems related to trigonometry.
The trig, yes, I see that now.
That is a very good base to have. Is that clear to you?
Yep.
Can you please read question number 10?
Yep. Two circles have a common tangent with points of contact as P and Q. Find the distance between the center of the circles if their radii are 3 and 5.
We need to find this distance. We are given the radii, which is, this is what is given to you. How will you solve this question?
So obviously the first thing we probably need to do is find, actually I'm not really sure.
Here's a trick. We know the radii. That means we know the distance from A to P, right? And that is a right angle, as you know, correct? What you have to do here is draw a line parallel.
Oh, okay.
Does make sense to you?
Yes.
Then you have a rectangle here.
And a right angle triangle.
Right? And another right angle triangle, right?
And then you'll be able to solve it.
You get it. That is how we do it.
Okay, got it then.
Here are the solutions for these two questions.
Yes, let's look at them.
I'd like you to go through these solutions, understand the strategies behind.
Okay.
Yeah. So can you just go through quickly through the solutions given in red?
Yes. So for question 1, let OC be right bisector for AB. Triangle OCA is a right triangle since the right bisector of a chord will pass through the origin. AC would be half of AB, which is 6. So add this to the formula. OC is equal to square root of 10 squared minus 6 squared, which is 8.
Which is also a Pythagorean triple.
Yes.
Now, you know 3, 4, 5 is a triple? This is just twice that. 3, 4, 5, 6, 8, and 10.
Okay. Oh, so yeah, what you said before makes sense now as well. Okay, okay.
Question 9.
Question 2. Angle BAC is equal to 120 degrees minus 30 degrees is equal to 90 degrees, which tells us
do it like this also. This is a very fast calculation. Well, only some students can do this calculation. This angle here is 120 degrees minus 30 degrees.
30 degrees.
How easily I found it. See, if I extend this particular line, then you know the north and north, and so this is 30 degrees. Is that clear to you, right?
Yeah, so it's equivalent angles. Okay.
And that is 180 degrees is full. Do you see the full thing is 180 degrees, right? So you can now visualize, we know that is 30 degrees, how we got this particular formula.
Okay.
So that's a very quick formula to get the angle inside. So you could do 120 minus 30 degrees to get that angle.
Yeah, it's much simpler than finding out. Okay, that makes sense.
Yes.
So once we
know it's a right angle triangle, then
we can just input yes.
Yes.
Question 3. Draw a line BD parallel to PQ. PQBD is a rectangle, which is PD is equal to QP, which gives us the length of 3. AD is equal to AP minus PD, which is equal to 2. So triangle BDA is a right triangle. So, input our values, and we get square root of 2 squared plus 12 squared is equal to 12.1 centimeters.
Perfect. So, there. How do you find this particular set of questions compiled for you on Pythagorean theorem?
I really enjoyed the 3D figures as well as the bearing question as well, because I've never really seen anything like it. And it shows me how, the Pythagorean theorem is added to questions that and it's going to be forever connected in future questions and things. I also really liked the proof of Pythagorean theorem questions, because in the IB program they demand that you always have a reasoning for your questions. So it'll definitely help me in the future to be able to justify my answers and my methods.
That's great. Very good, Dave. And I hope that really helps you. This is
it will for sure.
Yeah, this is the foundation for higher level mathematics you're getting into now, right? So seriously, go through this video once again. I'll just say that to you. Go through this video once again. Try to understand what all we have done today, right? And appreciate the way Pythagorean theorem can be applied in different circumstances.
Yes.
That will help you moving forward. And thanks a lot for being my student and here helping me in making this wonderful video.
Thank you. Thank you.
My pleasure. Have a great day.
You too. Thank you so much.
Thank you.